Precipitate lab, day 3. Okay, you can see some precipitates here and what it looked like at the end. This is something I actually threw away and pulled out of the garbage, but it'll give you some idea. And what happens is this would be number 1, this would be number 2, this would be number 3. This is pretty typical that these did turn black. And then number 4, some of them might have a little gray, some might not have. I don't know if you'd see a little gray in there. It's mostly blue. And then I think 5, 6, 7, and 8 were all blue with that precipitate right there. So again, 1, 2, 3, more of a black color. 4 might have had a gray in a little bit of it. And then pretty much for most groups, 5, 6, 7, and 8 were more of that blue color right there. Let's go to a screen share and talk about a couple things, especially for those who are absent and need some data to work with. So I am going to screen share here. Okay, and I might just scroll back and talk about a couple of the expectations for the lab, and then we'll go into the data that you could pick up. So first off, just a quick review of expectations. You are writing the balanced molecular equation, total ionic, net ionic, and then a picture like we did in the net ionic lab for the microscopic interpretation. Okay, for questions 5 and 6, you're looking for a calculation and then a description of how you made that solution. For example, I took whatever number of milliliters of 2.50 molar sodium hydroxide, and then I added enough water to get to 50 milliliters would be an example of what you're doing there using the value that you calculated originally. Okay, number 6 would be a similar thing, except you're doing it with a solid, and you can look at your solution prep examples for how to see how that goes. Okay, you had some observations. Data, okay, this is what we did with day 3. You got the mass of the filter paper plus precipitate, subtract out the mass of the empty filter paper, and you can get the mass of just the precipitate. Okay, in a moment, I'll show you which group you have, and you can get these numbers 1 through 8 going across, and then the mass of the empty filter paper is going to be the same all the way through here. Once you get that data, then you can subtract to find the mass of the precipitate, and you know what the precipitate is, copper hydroxide. You can convert to moles of precipitate right there. Okay, these calculations I think should be pretty straightforward. If you know liters and you know the molarity, which is 0.5, liters times molarity gives you the number of moles here, same thing here and here and here. Again, you're going to do the same thing with sodium hydroxide, which is also a 0.5 molarity solution. Okay, as far as color of precipitate filtrate, I think that's something you saw. I think a lot of groups saw this being clear in 1 through 3 and progressively getting more blue as you went from 4 to 5 to 6 to 7 to 8. So that could be some helpful things when you get to these analysis questions, which I'm going to give you some hints at because it brings in this concept of excess limiting reactant. Okay, before I get to those analysis questions, I'm just going to show you some of that data, which again can be like through 1 through 8, and then the mass of the empty filter paper. So here is that data that I got from the groups in case you're off someplace, stranded someplace for vacation or whatever it is. So if you're in group 2 on the east side, you're going to be having your 1 through 8 data are through here, and then this is your mass of your empty filter paper. If you're in the 2 west side, this would be your data, and that's what you'd be using. Okay, again, I think a lot of you did either day 1 or 2, but then we're gone for the Monday, the 28th, when we came back, but this would be the data you could use. Okay, period 3 near the periodic table, which would be the east side. This would be your data. In period 3 on the goggles side or the west side, this would be your data right here. Okay, so you can take a look, match that up to your class. However, if you're in periods 4 or 5, you're gonna be doing the same thing. And I think it's probably fair to say, if I drew this in here quick, I could draw a 1 here. This would be, oops, maybe I can't draw that in there. I'll call this one 1 right here. And we'll skip a little bit here. This would be number 2. Skip a little bit here. This would be number 3. Skip a little bit here. This would be number 4. And we'll just come over here and do 5 right here. 6, 7, and 8. So if you were in periodic table side for period 4, or the goggle side for period 4, these would be your numbers. And for period 5, these would be your numbers for test tubes 1 through 8. And then this column right here on the far right is your mass of your empty filter paper. So again, you're going to take, if you had test tube 8, it would be 1.52 minus 1.20. If you're in the goggle group for this one, and you're going to figure out, oh, that's 0.32 grams. You're going to use that as your moles and ultimately find the molar mass there. So hopefully that helps getting your data out and you can take a look at it right there. Okay, I'm going to go back here to this and let's see, I'm going to erase those things, go back to my spotlight, and I am going to look at these questions because it asks about what tube should contain the greatest amount of precipitate and why. All right, and let's see. So, and what reactant is in excess in test tubes 1 and 2? What reactant is in 4 through 8? So I'm going to just go through a little comparison to do this. I'll erase these things out of here. Okay, so we're set to go. And this is a little comparison I have. So think about it like this. If I took 2 pieces of bread plus 1 piece of cheese, I can make 1 sandwich, okay? And notice if I took, let's say I had 8 pieces of bread and 1 piece of cheese, okay, I'd make 1 sandwich and I'd have 6 extra pieces of bread. If I have 7 bread and 2 cheese, I'd make 2 sandwiches and have 3 extra pieces of bread. If I had 6 and 3, I'd make 3 sandwiches and have no excess of either reactant. Okay, if I had 5 and 4, and assuming I could cut the cheese or slice the cheese in half, I could take 5 pieces of bread, 2.5 pieces of cheese, make 2.5 sandwiches with 1.5 pieces of cheese left over, and so on. 4 and 5 gives me 2 sandwiches, 3 and 6 gives me 1.5, 2 and 7 gives me 1, 1 and 8 gives me 0.5. Notice I have excess of cheese, progressively gets bigger here. Okay, here is the biggest amount, which gives me the most sandwiches in this third case, and then these ones I had excess bread. Well, we're going to draw an analogy of this to our lab, because in our lab we used, instead of slices, we used milliliters. But because we have the same molarity here, these milliliters correspond to amount of moles. So there was an 8-to-1 ratio and a 7-2 and a 6-to-3 and so on, always using 9 milliliters right there. So we're going to be looking for the optimal ratios and ultimately look at this. We have, notice the bread is like the sodium hydroxide. Okay, in 1 and 2, the bread was excess. Well, in one test tube 1 and 2, sodium hydroxide is in excess right here because you have a greater than 2-to-1 ratio. Okay, in number 3, it should be the optimal amount because it's just right because you have the optimal ratio, 2-to-1 of bread to cheese, 2-to-1 of NaOH to copper nitrate. Everything gets used up, no leftovers. That should give you the most. And let's see, in 4 through 8, what do you have most of? You have, or what do you have excess of? You have less than the 2-to-1 ratio of bread to cheese, or in this case, of sodium hydroxide to copper nitrate. So you have excess cheese, or you'd have excess copper nitrate. And I think that will help you answer what you should be getting for these questions. If you look at that analogy and look at the questions that are asked, and they say, oh, what tube should contain the greatest amount? That's the one with the 2-to-1 ratio. Okay, what reaction is in excess in tubes 1 and 2? What's in 4 through 8? Go back to that analogy and relate that to what you have going on there. Another hint is the color that drips through the filter paper. Remember that your copper nitrate is blue and sodium hydroxide is clear. So if I have a blue filtrate dripping through, I'm guessing that in those cases, the copper nitrate would be excess. So that would be another hint right there. The final hint that I will give you is when you look at your conclusion, some of your data might not match up that you're given. So identify anything that seems to be a discrepant result. Remember, your biggest should be the middle at number 3. Your smallest values should be on the sides. All right, so if I go back and look here, just like I did with the sandwiches, the smallest numbers are what for amount of product are on the sides. As you get toward the middle, it gets bigger and it peaks at number 3. So any data that doesn't match that trend, you should be identifying that and coming up with a possible cause why that occurred. All right, so hopefully that helps again, and make sure you grab the data that's you need for your group, and then you can start working and processing that. Let me know if you have questions. Thank you.